So nothing new today as far as different material, just making sure we've got down some of the stuff that we've been learning about this week as far as our polynomials go. So, state if the given binomial is a factor of the given polynomial. Okay, here's what that means in English. Is the remainder 0? That's basically it. We're going to be using synthetic division to see if the remainder is 0. If it's not, then it's not a factor. If it is, then it is a factor. And that's kind of the way we're going to be taking a peek at this. So let's say we take a peek at number 1. We go, okay, first thing, and it's critical because if I do this wrong, I'm kind of done for the whole problem. If we're given a binomial, okay, as our divisor, we're going to use the opposite as the value in our little box. Now let me show you again why that is. Because if I'm looking for this 0, and I would actually work this out and solve this out, okay, that's the value I would get. That's my 0. That's my intercept. And so that's why we're going to use this as the value that goes in our box. Now, the one other thing we've learned over time with dividing synthetically is, are there degree gaps? So I start looking and I go, all right, let's see here. 3, 2, 1, 0. Okay, this one goes the way it's supposed to. It goes down one step at a time. So I'm going to copy my coefficients down and run that process that we've been doing a lot more lately. So first term comes down. Don't mess with it. Don't multiply anything. Don't change it. Just leave it alone. Once we get that down to the bottom, we take that number and multiply by what's in the box. So 5 times -2 is -10. We're going to add down. Okay, keep your signs with it. We're going to multiply. We're going to add down. We're going to multiply. We're going to add down. Now, before I make my decision on, yes, it's a factor, no, it's not, I'm going to go ahead, I'm going to put my variable terms back in. So like we've done before, I'm going to take that exponent, my 3, my degree, I'm going to reduce it by 1. So 2, 1, constant, and that number left at the end is my remainder. So in this case, that is going to, thank you, that is going to tell me, this piece right here, that p plus 2 is not a factor. Anything besides 0, the answer is no. I still rewrite it, I still show my remainder, and that's my reasoning for why it doesn't work. Now, I'm going to change up here on you for a second, just because I want to make sure, we talked about degree gap, I want you to make sure that you see one that's that way. So actually, I'm going to jump down to number 5. So when I get to number 5, I go, okay, my R value I'm going to plug in is 7, because again, it's going to be the opposite of the sign that I see. And I start to look. And you might be like, well, he said this is going to be one of the degree gap. Okay, let's see. 3, 2, 1. You're like, 3, 2, 1. What's the big deal? What's he talking about? Okay, let's think about most of these, though. 3, 2, 1, 0. I need a constant term at the end. If I don't have one, and I don't here, I don't have that 0 degree term. Okay, so I need that. So when I'm writing my coefficients, so we assume there's 1 in front of the r cubed, and -1 in front of my r, I have to have that 0 at the end. Normally we've seen them in the middle, but they can be at the end as a constant term. Everything else is going to stay the same. Pull my first term down, multiply it by what's in the box, add down. Multiply by what's in the box. Again, 0 times 7 is 0, not 7. Add down. Multiply by what's in the box. Add down. So I notice that it's not going to be a factor because this didn't equal 0, but I'm still going to take my degree, my 3, reduce it by 1. 2, 1, 0, remainder. Okay, but that's what I'm looking at. Again, any number there besides 0 is going to be no. Okay, if I get 0, it's going to be yes. Yes. Good question. Would I still need to put the remainder? In that case, it's going to be no. If I just get a 0, I wouldn't have to. So let me think here for a minute. I'm going to find one where that's the case to make sure that we've got one of those here too. Okay, let's do number 2. Then we can see the next part here and kind of get a feel. So I switch that. So that's going to be negative 9. So once I get that, now I'm going to go through, look for my degree gap again to get going. Thank you. So 3, 2, 1, 0. Write my coefficients. Don't get spooked off by the fact the numbers are a little bit big. So I'm going to bring that first value down. Multiply by what's in the box. Add down. Be careful with your signs. If I flip a sign, that kind of messes up all the rest of my numbers. So even if you have to, go to your calculator if need be. Negative times negative is positive. Add down. Negative times negative is positive. Add down. So again, before I write yes, no, circle anything, get your variables put back in. Start with 3, we're going to 2. We're going to 1. There's my constant. And if this is 0, I wouldn't mark it wrong if you put 0 over a plus 9, but normally that would just be what I have left. And that 0 tells me that yes, this is going to be a function. When we get to the unit test, you cannot just flip a coin and say 50-50 guess and write yes or no with no work. Okay? We've got to actually show why that is when we're doing these. So that's one thing that we're up to today. It's figuring out if our factor is going to be, if our factor is or is not a factor of the polynomial. Now, one of the other things we got into yesterday here, we're going to take a look at a couple of these. Okay, sketch the graph of the function, find the minimum and maximum values along with the x-intercepts. Okay, now we're right on task with what we were doing yesterday. So I get here, calculator, definitely a good idea because we're not going to get things that are always going to come out as clean answers with these. And I even chatted with my afternoon classes yesterday. I said, okay, the windows need to be back to normal with things. I told them that if theirs weren't, that I would start harassing people about this. Just crazily not harassing. That's a little bit extreme. But here, let me bring down our shine factor a little bit so we can actually see it. Okay. If there's stuff in the y equals, we're going to clear that out. But before we get going too far, so we're all looking at the same picture, we're going to go to the window. Oh, one of my afternoons, bad people. No. My maxes and mins, my mins should always be negative 10, my maxes should be positive 10. So if we have to put some of them back to where they belong, so we're all seeing the same thing, that's probably a good idea. So again, that's window. Let me move this up so you can see that. Window, and then we want mins at negative 10, Max is at positive 10. That should really be the only thing that people would be moving around some. The other thing we're going to double check just to be sure, even though this I don't see why it would be changed, would be the table set, which is second and window. Okay, typically that's going to start at 0 and then it counts by ones, even though if it started at a different number, it really wouldn't matter that much. Okay, so second window to get here, we want that at 0 and 1. Once we got that set, we're going to go ahead and we're going to get this typed into my y equals. So negative 2x squared plus 4x minus 2. Once I have that, it doesn't hurt to take a look at the picture before we get started too much with it. See, am I going to be able to see all the important parts? Now I notice it's just a parabola, which makes sense. It's a quadratic. Whoops, it's a quadratic. It's squared. So I'm going to have a maximum. I won't have any minimums with this one. So I can see my turn, and I think I can see where maybe the x-intercept is. So let's see if we can find it out easy. If I do second graph, and I find a y equals 0 value, that is an x-intercept. Now, do I see any others? Let's see here. No. Nope, just looks like to be that one. So, okay. So I have an x-intercept at 1, 0. Now I'm going to pull the picture back up for a minute because I notice, I'm like, hey, it doesn't look like it goes through anywhere else. It's just that one. But I also know, because of my degree, that there has to be 2 zeros. There has to be 2 intercepts. But I've only found one. What's the deal? Oh, yeah. This is bouncing off of the axis. It's not going through. It's getting to the x-axis and it's moving. So this, okay, is a double intercept, a double root, or it's our rule of multiplicity, which we're going to talk about again here in a little bit. So when I go to graph, I've got this 1, 0, and that's really the only point I've got to work with. So in this case, maybe going to my chart and grabbing an extra value or two may not be a terrible idea. Normally, we'll use our intercepts and our min and max to do this, but here's the other thing I'm going to learn from this. When I go to do my max, which again is second trace, you might even want to pull out your note sheet from yesterday just to have a reference there. We're going to be looking for the max because it looked like a hill. We're on the top of the hill. That's what that is. And just like we did yesterday, we're going to use the right and left arrow buttons to try and get as close to the top of the mountain or the hill as we can. Once we get there, we're going to go left 1, 2, 3, 4 times. And even this will kind of remind you which direction to go. I hit enter. I set my first border. Then it says right bound, so I start with the right arrow. 1, 2, 3, 4. That gets me back to the top of the mountain. 5, 6, 7, 8. We hit enter again. Our trap is now set to find the maximum. I got it surrounded on both sides. And we're going to hit enter one more time to catch it. And it says my maximum is also at 1, 0. Now, does that happen often where they're the same? Not really. But it will happen sometimes, which is one of the reasons I thought this would be a good one for us to check out as far as that goes. Now, a more traditional one might look like, let's say, number 13, where we're going to get to do a little more calculator work. So let's jump down to 13. It'll look a little stranger, but that's okay. So 13, I look right away. 4 zeros. Okay? 4 intercepts. So, when I go to get this typed in, I probably should be able to see it. That would be helpful. So, X, once again, here's my caret button to get to my exponent. My right arrow to get back down. Minus 4x squared minus 3x plus 2. So once I get that in, I make sure my signs are good, my exponents are good. Okay. So let's take a look at the picture. That's kind of funky. So I notice a few things. I'm like, okay, let's see. I notice I see 2 intercepts. We'll chat about that in a minute. And I see 1 minimum, 2 minimums. I see 2 valleys and 1 top of a hill. It's not a very big hill, or like a bump, but it's still there. So I start to look through and I go, okay, X-intercepts. We need to do that first. Let's see if we're lucky again. If we look at our chart, oh, don't look lucky. I don't see any zeros in the Y column. Okay, so that's not going to help me. So I'm going to need to do my second trace, get my calculate menu, and we're going to have to go looking for them. So just like we did on the maximum a minute ago, I want to get my cursor as close as I can to the x-axis. That's pretty good. And then I do the same process. Left bound, left, 1, 2, 3, 4. Enter, there's my first border, my first boundary. Get ready to set my trap. Right bound, 1, 2, 3, 4. Gets me back where I started. 5, 6, 7, 8. I hit enter, my trap is now set. I got my outer borders ready. And to get it, 1 more enter. Okay, and we get decimally. This is more realistic for what we're looking at. So 0.430 is one of them. So we can kind of plot that between 0 and 1. I notice there's a second one, though. Let's try this. That's better. I notice I can see a second one. So I start the process over. I got to do second trace again. I can't just start moving. I'm looking for a 0, and I'm going to move my cursor over that way. Now, whoa, there it went. Sometimes I'm not really going to get close at all. That's as close as I can get. That's okay. So left bound, left, 1, 2, 3, 4. Enter. Right, 1, 2, 3, 4. Back where I started. 5, 6. Don't worry if it disappears. 7, 8. Enter. My trap has been set. Catch it with 1 more enter. So 2.22. And again, like we talked about yesterday, E just means 0. Because like we'd had, that E just means it's 1 to the negative 12th power. In other words, 0.00000000001. That's really close to 0. So we just call it 0. So we can get that one plotted in here. Now at this point you may say, well, wait a minute. There's supposed to be 4 zeros. I only see 2. What's up with that? The other 2 are imaginary. We are not worrying about that. Okay, we're just worrying about the x-intercepts, the one we can see. We could be thinking about that though. So now we can change our focus to the maxes and mins. So let's start with the mins since there's multiples. You'll never guess how we get there. Second trace, same menu. So we're looking for the minimums. We're looking for the valleys. So I work my way back over here to the left. And I just like working left to right. I could have done this one first. My little tiny valley here. Try and get down to the bottom of it as best you can. And now it's the same thing. Left 4. 1, 2, 3, 4. Enter. Again, use that as your clue on what direction to go. Right. 1, 2, 3, 4. Back where I started. 5, 6, 7, 8. Trap has been set. Catch that minimum. So let's see here. Negative 1.16 and 1.91. And we're good to go. So not bad. But I do have a second one. I start my process over. So we're looking for a minimum. So I get my way over to that minimum as close as I can. And you know the drill at this point. 1, 2, 3, 4 to the left. First border set. 1, 2, 3, 4. 5, 6, 7, 8. Trap fully set with both my borders. And catch it. 1.57. Negative 6.49. And I'm going to move the calculator out of the way for a second because I don't want some of you thinking that's a bracket. It's a parenthesis. So I can guesstimate to the best of my ability where those two dots are going to be. Okay, we're just trying to make sure our graph is as accurate as we can make it. So I got one piece left to find. I have one very small hill up here. Now again, this is kind of the opposite extreme. Usually won't have this many values, but occasionally we do. So again, I try to get to the top of that little hill. Hint there on my direction, left. 1, 2, 3, 4. Enter. Right. 1, 2, 3, 4. Back to the top. 5, 6, 7, 8. I have now set my trap. My boundaries are in. The only thing left to do is hit enter to catch it. At negative 0.41, 2.59. So, yeah, that's right. And now I've got a picture to kind of help me see what this is going to look like. So I can through here. Okay, and I get something that looks kind of similar. But again, that second trace table, having a feel of that is going to be critical in you being able to see how this all works. Okay, and make it work through there a bit. So that's what we're going to be doing in the graphing part. And again, if you don't get these done in class, then there really wouldn't be a reason not to. But if not, again, I put up the two different phone apps that I normally go with, the Wabademu and the Free Graphing Calc. A few people were impressed yesterday at how quick you can get some of these values using those as well. Okay, one last thing to go back over. Polynomial functions. Write a polynomial function of least degree with the integral coefficients that has the given zeros. In other words, we want these looking like the original problems on the last page. How do I do that? Okay, these are all my X-intercepts. These are all my roots. So my first job is to get them back into binomial form, typically, which I do by doing the opposite. Because if you think about it, if I have x equals negative 5, that came from this. X plus 5 equals 0, I minus 5, I minus 5, I get here. So that is how I'm doing that. But again, it's just the opposite. Opposite of positive 1 is negative 1. And if we have a 0, I just use x. So once I get those written, I can actually do them in any order I want, but I'm only going to work on a pair at a time. So typically I'm going to do the bigger ones first. I'll save the distributing with x for the end. So here is where I do my box or my foil. Again, when we're doing these, we are adding exponents if both terms have a variable. We are multiplying coefficients. Detail, detail, detail. Once the box is full, multiplying is over. Combine like terms, 5 minus 1 is 4x. x. Don't mess with the exponents anymore. That is my first pair. Does that mean I'm done? Nope. All that means is now I'm going to take this, and the only thing I have left is an x. If it would have been another set of parentheses, another binomial, I'd have made a bigger box. But I don't really need to make a bigger box for this. I could make a box, but I don't need to. And I'm back doing my multiplying. I'm adding my exponents. And there's my binomial term. My polynomial, excuse me. That would be a trinomial. And we get that set. Now, the only other twist I can think of that could get thrown your way is, again, multiplicity, which we talked a little bit about on the last page when we had our bounds. Multiplicity just means that value is showing up more than once. So this, -2, multiplicity of 2, 5, means there's 2 -2's and a 5. This number tells me there's 2 of those. So like, for instance, if you get down to number 19 that says -3 multiplicity of 3, we have -3, -3, -3. That's what we're basically doing. So I go to write my binomials, again, switching signs on every one. And now I'm going to multiply this out. Pair at a time. This is getting me so much practice with basic multiplication skills and detail work that comes in handy as we do these. Again, multiply rules to fill in the box. Once the box is full, we're just combining like terms. But this time, my last factor is another binomial. Okay? We can't just distribute on that. So we're going to go to a bigger box. And boxes can be any size. 2 by 3, 2 by 2, 3 by 3. Doesn't matter. So I've got my x minus 5 that's still left here to go along with my trinomial that I got from the first step. Now again, back to the same rules. Add your exponents. Multiply your coefficients. Watch your signs, especially when you've got positives and negatives that you're playing with. And then just start writing your terms from greatest degree to least. Again, watching signs. -5 plus 4 is -1. -20 plus 4 is -16. Three zeros, degree of 3. So your job, to play with the rest of them. Make sure you're an expert at this, because that way when you start tomorrow on the review, that's not going to be something you have to spend as much time on as maybe some of the stuff at the start that you haven't seen in 3 or 4 weeks on a regular basis. So we'll get that out to you tomorrow. The end of this whole unit is coming near. Hopefully we got you ready.